Okay, let's proceed, please. So we said the course title is Introduction to Measurements, Introduction and Measurements. So the course code is PHT 107. The learning objectives. By the end of the course, by the end of this particular class, we expect that the students will be able to explain measurements, know the measurement systems in pharmacy, explain each of the systems, and describe the measures that each of the system covers. Those are the learning objectives. The students should be able to explain measurements, know the measurement systems in pharmacy, explain each of the measurement systems, and describe the measures that they cover. So before we go further, what is measurement? When we say measurement, what do we mean? So in science, measurement is the fundamental process of assigning numbers or symbols to physical quantities to describe them objectively. When you assign a number or a measure or a symbol to a physical quantity to describe it, you're doing measurement. How do we mean? You can basically I've been doing measurement on a daily basis. You can ask somebody, please get me a cup of water. You're simply measuring the quantity of water that you need. I need a tablespoon of salt. You're measuring the quantity of salt that you need. Please, I need a basin of water. That is also measurement you're doing. So we say that it involves comparing an unknown quantity to a standard unit and provides a clear, concise, and quantitative way to communicate observations. Now, if you listen to examples I cited, when you say a cup of water, right? It's clear enough, it's concise. You're asking for water and you're asking for just one cup of it, right? We say that scientific measurements use established systems. One of those systems is the international unit, the international system units. And why do they use those systems? They use them to ensure accuracy, consistency, and reproducibility across experiments and scientific disciplines. If you measure something, let's assume you measure a length and say, I measured this length. The length was 10 feet. If some other person measures it, the person should be able to get exactly the same value you got. So that's what we mean by reproducibility. Next slide. It is also the process of assigning a numerical value and a unit to a physical quantity or property. I've cited instance already with length, weight, temperature. There are so many of them. You can say, probably when the baby is born, you say, what's the weight of the baby? Right? You say, okay, maybe this baby is 3 kg, 4 kg. You're assigning a numerical value to a physical quantity or property. That is measurement, right? It provides a way to describe objects and events precisely, just like we said before. Precise, straight to the point, which is fundamental to scientific experimentation, engineering, pharmacy, and everyday task, right? And it ensures that information can be clearly communicated and reproduced. If you tell somebody, I want water, how? What quantity? What do you want to use it for? Right? So when you place some measurement on them, when you place some more value on them, your communication becomes clearer, right? And it means that whatever thing what object you're describing can also be reproduced. Now, we measure almost everything in our daily lives, right? In fact, measurement gives meaning to variables, items, and even life itself. How do we mean? Some persons have lived their life and probably they are dead. Probably you see an obituary announcement and you see late so, and so. You see something like 1940 to 2025, right? They have measured the amount of time that that person lived. That is what it means. That is how important measurement is in our everyday life, and especially in pharmacy. It is very, very necessary. Without measurement, a lot of things will be chaotic. Now, we've looked at measurements in a nutshell. So what are the kinds of measurement systems we have in pharmacy? In pharmacy, we have four types of measurement systems. The first one is the metric system. The metric system is the old name, actually. The new name now is the SI unit, that is the System International Unit. That is one that is widely used across board. We also have the apothecary system, apothecaries. We have the avoidable system, and we have the common system of measurement. That common system, a lot of persons also describe it as a household system. So these are the four basic systems we have, four basic systems of measurement we have. The metric system, the apothecary system, the avoidable system, and the common or household system of measurement. Now, these four, we'll just describe them briefly for the purpose of this introduction. Then in subsequent classes, we'll begin to go more details about them. So let's look at the metric system. Now, the metric system is now known as the SI, System International Unit of Measurement. The metric system is the old name. Now, in pharmacy, you will be dealing with the metric measurements of length / height, volume, and weight. Now, for length, when you're measuring length, basically you measure length in meters. When you're measuring volume will be measured in liters. Length or height, meter. Volume, liter. Then weight is in grams, right? Now, it's likely that you may know some of these prefaces and all that, but we'll look at a few of them that you encounter in your practice, right? Remember, the metric system is what we're looking at now. And we have said that the common metric systems you'll be measuring is length / height, volume, and what? Weight. Length, you measure in meter. Volume, you measure in liter. Weight, you measure in grams. So let's look at some of the common prefaces that you meet in the system unit. Now, for when you say kilo, that's the preface. The abbreviation is K, and that is 1,000. So you say a kilogram of salt. You're simply referring to 1,000 grams of salt. Now, deci, which is the next one. Deci, the symbol is D, and that is 1/10. 1/10. So you also have deciliter. When we go further, you see that some drug concentration are actually reported in grams per deciliter. We have centi. Centi is 100th, right? 1 out of 100. Then we have centimeter, cm. Patients' heights are often converted from inches to cm, right? Cm, centimeter, meter. Okay, we have milli. And the prefix for milli is m. And that is 1,000. That is 1 out of 1,000. We have milliliter. Most injectables, like most injectable drugs, are measured in milliliter. The next one is a micro. Micro is 1/1,000,000th. That is 1 part of 1,000,000, right? Now, drugs that are required in very low concentrations are measured in micro, 1 out of 1,000,000. We have the nano. Nano is 1/1000,000th. 1/10000000th. We have the nanogram. Drugs too that are also required in very minute and tiny bits are also measured in nanogram. Drugs have very low serum concentrations, and they are measured in nanogram per liter. We have the pico. The pico is 1/1,000,000th. 1/1,000,000th. That is 1 in a trillion. A few drugs have barely detectable concentrations. You will barely see this one, you barely. So those ones are measured in pico. So if you watch how we're going, we started from kilo, 1,000, to deci, 1/10, centi, 100, milli, 1,000, micro, 1/1,000,000th, nano, 1/1000,000,000th, pico, 1/1,000,000,000th. So that's the brief about the metric system. That's the System International Unit System. So let's look at the next system. We said that in pharmacy, we have 4 kinds of measurements, right? We said the metric system, the apothecary system, the avoidable system, and the common or household system. So we've looked at the metric system. Just briefly, this is just like a brief intro. We'll take our time and go more details in our subsequent classes. Then the apothecary system. Now, that's the second one. Now, the apothecaries are that's the old name of pharmacists, right? This system was used by the old-time apothecaries. That's the old-time pharmacists, forerunners of today's pharmacists and pharmacy technicians. In this system, 1 troy pound was made up of 5,760 grains. The apothecary system was used by the very old pharmacists. They were referred to them as the apothecaries. And their system of measurement then was the apothecary system, right? We said that 1 pound in their system, in the apothecary system, 1 troy pound was made up of 5,760 grains. Like I said, brief intro. Subsequently, we'll go details. The next system, just remember, this apothecary system, just remember that it was used in the days of old by the early pharmacists and pharmacy technicians. And then that system, they measure in troy pound, and one of it contains 5,760 grains. Now, the avoidable system. The avoidable system is Roman in origin, but it had a French name and was adopted by the English as standard for weights in commerce, right? What it means is that when they are transacting in commerce, when they measure something in weights, they measure it in the avoidable system, right? Now, see how the spelling is, but you see how it's being pronounced. It's being pronounced as the avoidable, right? An avoidable pound is divided into 16 avoidable ounces. And 1 avoidable ounce is made up of 437.5 grains, right? For the apothecaries, we say that 1 troy pound of it is 5,760 grains, right? Now, for the affordable system, 1 affordable ounce is made up of 437.5 grains. Let's try to remember a bit of this so that when we proceed, we can use them as a reference point. Next slide. The common or the household system. Now, remember, we have briefly mentioned the metric system. We have mentioned the apothecary system. We have mentioned the avoidable system. Are we together? So the next system is the common or household system. Now, this particular system combines bits of the apothecary and the avoidable system, and also through a couple of measures found in neither of them. This is the system that is commonly used in the United States. Now, in this system now, I just try to put a little bit more of it. So let's just look at them briefly. Now, 1 gallon is equal to 4 quarts. 1 quart is equal to 2 pints. Remember, we say maybe you see a patient in the hospital that needs blood. They say, go and buy 1 pint of blood, right? You see now there is a unit of measurement. It's not just a word on its own. So that's to measure the amount of blood a person needs. So 1 pint here is equal to 2 cups. 1 cup is equal to 8 fluid ounces. 1 fluid ounce is equal to 2 tablespoons, right? 1 tablespoon is equal to 3 teaspoons. 1 pound is equal to 16 ounces. 1 yard is equal to 3 feet. 1 foot is equal to 12 inches. At least you can easily remember this one. 1 foot. 1 foot is equal to 12 inches. That's like a ruler. The primary school ruler we use then. You see the ruler has 1 foot and it contains 12 inches. 1 yard equal to 3 feet. Now, you may not necessarily need to memorize all this. As we go, some of them will come in more frequently, and gradually, you will learn to remember them. Right? Now, at this particular page, just try to do a summary. Then after that, I will entertain your questions, and probably any issue you have to raise. Right? We have said that measurement gives meaning to physical quantities or properties. Measurement gives meaning to physical quantities or properties. I try to cite an example. 1 cup of water. I need a bottle of wine. I need a spoon of salt. Please go and get me a loaf of bread. Now, if you're not conscious, you may not understand that these are not just mere words. These are actually quantities, right? That's what I'm saying here. Measurement gives meaning to physical quantities. Without measurements, a lot of physical quantities, we may not appreciate them, like their size or their quantity, right? Even people that build in the construction industry, you hear things like a bag of cement. Bag of cement is 50 kg. And you might see things that they say, okay, maybe you might need like 10 bags of cement to do this. Assuming there is no way of measuring it, how will you know what quantity to use? Right? Now, in pharmacy proper, you will see at times they'll write a prescription. 2 tablets of paracetamol morning, 2 afternoon, 2 evening, right? That's like saying 2 tabs 3 times daily. That is measurement. Do you understand? That is measurement they're referring to. Now that's what's here. Measurement gives meaning to physical quantities or properties. In fact, I'll add that measurement gives meaning to life. I'll add that measurement gives meaning to life. Because if things are not measured, there will be a lot of misinformation and misjudgment. And in pharmacy in particular, if measurement is not done properly, there will be a lot of morbidity and mortality. Right? If you are required to give probably 2 tablets of chloroquine, and instead of giving 2 tablets, you go and give 10 tablets. What are you looking for? Trouble. Trouble, big one. Right? That is how important measurement is in our everyday life, and especially in pharmacy. Measurement is a basic phenomenon. Measurement is something that we should try and take very serious. Right? We can go on and on. Everyday life, even our shoe. You say, what is your shoe size? I wear size 40. I wear size 35. That is measurement. Assuming you're not able to measure your shoe size, what will happen? So let's assume you're size 35. Somebody can go to market and buy size 45 for you. Will that work? Definitely will not work. What are the clothes you wear? Waist size. You can say, okay, my jean, what's your waist? You say, my waist is 38. 38 what? 38 inches? So somebody is going to buy, you say, okay, I need a trouser that the waist is 38 inches. What of the length of the trouser? If you don't know the length, what happens? Probably you go and buy somebody a short knicker in place of a trouser. Right? So that is how important measurement is. Measurement is as important and very, very crucial as that. You can always apply it everywhere. Assuming you're preparing food, somebody can write a recipe down for you and you follow it. That recipe, the only way you can follow it correctly and get it right is because it is measured, it's graded. Add half spoon of salt, half spoon of pepper, 2 cubes of Maggi, right? Those things are measured. That's the only way you can get the recipe right. Are we together? Now, in pharmacy, your formulations are as good as you're cooking a soup. Just look at it. So for you to prepare when a particular formulation is being prepared, there are ingredients that needs to come in. And those ingredients are measured and graded. Those ingredients are what? Are measured and graded. Your syrups, your suspensions, like probably you go and buy your anti-malaria, right? Most of the ACT combination, you see, it's not just one component. You have maybe like 2 components or 3 components. And you see how many milligrams of each of the component that is contained in making that particular preparations. So you see the need, you see how important measurement is. Without measurements, pharmacy will not be properly guided. Remember, Our traditional medicine, the issue that people have with it most of the time is they argue that there is no proper measurement to our traditional medicines. And they could be correct in their argument, right? They say, okay, maybe you cut this leaf, cut this root, cut this one, boil. After boiling, take 1 glass. Now, even if that sounds like a measurement, but the measurement is not, when it comes to drug proper, the measurement is not properly guided. It's not precise. Because you may have a glass that is, let's say 35 cl. Another person might have a glass that is 50 cl. Another person might have a glass that is 60 cl. Is it the same quantity now? Definitely not. You see the place of measurement in our everyday life. And when we bring it down to pharmacy. Now, if you're watching, if you're listening to the instances I'm citing, you'll begin to appreciate how important measurement is, especially in pharmacy. If you miss measurements, there will be a lot of problem, there will be a lot of trouble in the world of pharmacy, right? So we have said that there are 4 basic systems of measurement in pharmacy. One of them is the metric system, formerly metric system, currently the System International Unit, that's the SI unit. And that is the most current system of measurement that is being used now. The second one is the apothecary system. Now, the apothecary system was the system that was being used by old pharmacists, old pharmacy technicians, right? Where they measure in troy pound, right? Now, the next one is the avoidable system. The avoidable system. We said that system has a Roman origin with. Hello, please mute. Who is playing the music on the background? So we have they said the avoidable system is a system that is Roman in origin, but its name is French and was adopted by the British system and they use it to weigh for weight in commerce, right? That is the avoidable system. Then the next system, the last but not the least, is common or household system. And say that the system is commonly used in the United States. And just like them implies it, household, the common or household, you see them, they're measuring in gallon, they're measuring in yard, they're measuring in pound, they're measuring in feet. Now, you know that weight can be measured in pound, but pound is like the system implies, is an old system of measurement anyway. Yard and feet, that's measure of length. Foot inches is also a measure of length. Then questions. 3 questions there already. Now, if you're able to answer these 3 questions, it means that we are in tune with our objective for this particular class. What is measurement? 1. 2, why do we measure? 3, what are the measurement systems in pharmacy? Those are 3 basic questions we have for this class. So can anybody in the class attempt any of the questions? Or basically, if you have any question to ask, you can unmute yourself and ask. If you want to attempt any of these questions that I've asked here, what is measurement? Why do we measure? What are the measurement systems in pharmacy? If you can attempt any of them too, you can also unmute and answer. Or if you have any question you want to ask in relation to what we've discussed now, you can also do that. Unmute and speak, please, so we can hear you. Any question? Any clarification? You want any clarification? You want me to recap? I can easily do that. Question, contribution. There is any clarification you want? Our time is fast spent, but we'll still have some minutes to go. That's the end of the lecture anyway. Thank you, but let me use a few minutes to recap. We said that this course we looked at now, the course title is Introduction and Measurements. Introduction and Measurements. Now, we may not do measurement in the biggest of details, but want to introduce measurements. That's the aim of this particular course. Now, for this particular class, what are the objectives? What are the things we expected to have learned in this class? We should have been able to explain measurements. We should be able to know the measurement systems in pharmacy. We should explain each of the systems and describe the measures that the system covers. Right? Now, measurement, we describe it just in a very simple way. The process of assigning numerical values and unit to physical quantity or property. When you assign a number or a unit to a physical quantity, you have done measurement. You have a rope. You don't know the length. The only way you can know the length of that rope is when you measure it. You say, this rope is 10 feet. This rope is 5 feet. When you do that, you have done measurement. When you assign a number, a numerical value, or a unit to that physical quantity, you have done measurement. You have rice. You just pack some rice, put in a bowl. They ask you, prepare 4 cups of rice. You need to measure it to know. When you use a cup and measure, and that cup must be standardized, it must have particular size. You measure 4 cups. It's okay. This is 4 cups of rice. This is what I have to make. You have done measurements. You are assigning a numerical value or unit to a physical quantity. Right? When most of the time, you see when people go to the clinic, when they're taking their vitals, they check their weights, right? They check their weights. You could see somebody record 70 kg, 80 kg. The 70 or 80 is the value you have assigned to that physical quantity of weight. That is measurement. They measure the person's height. They say this person is 1.5 meter. That is measurement. You have assigned value, you have assigned number, you have assigned units to that physical quantity. When you do that, you have done what? Measurement. In a very simple way. When you assign a number or a value or a unit to a physical value, you have done what? Measurement. And we say that in pharmacy, measurement is what? Very, very important. Measurement is what? Very, very essential. Without it, there will be a lot of morbidity and mortality. In fact, put it the other way, without measurements, there will be a lot of accident in pharmacy. Right? So that is why in pharmacy, we need to measure. We need to know measurements to know exactly what to take and how to take them. Remember, there are some medications that are given based on body weight. There are medications that are given based on age. There are medications that are given probably based on gender. How will you differentiate? How will you now know? When you see a prescription, the whole idea of a prescription is anchored on the principle of measurement. Because what is written down, detailed description in that detail of the description is actually a measure. Give this quantity of this at this particular time, at this rate, like this. That is simply measurement. And we have said that in pharmacy, there are 4 basic systems of measurement: the metric system, the apothecary system, the avoidable system, and the common or household system. And we have also said that in subsequent classes, we'll take each of these systems in detail and do more justice to them so that we can understand and appreciate them better. So the questions, I've answered them already. Question 1, what is measurement? We've answered. When you assign a number or a unit to a physical quantity, you have done what? Measurement. Why do we measure? Why do we measure? In all this explanation, you should be able to pick why we measure. Why do we measure? Why do we measure? We measure for the sake of clarity. We measure to be precise. We measure to avoid accidents. We measure to avoid morbidity and mortality. In a nutshell, we measure to make sure that safety is maintained. The last question, what are the measurement systems in pharmacy? That are very simple and cheap already. The metric system, which is now the SI, System International Units, the apothecary system, the avoidable system, and the household or common system. I think we can say we have come to the end of the class at this point. Thank you. We still have a couple of minutes. Any question, we can still entertain it. If there's any question, we can still entertain it.